Hello, my dear friends. My name is Milad Amirian and this is the sixth episode of the Kubeflow Introduction course. In this episode, I'm going to take a look on the most important section of the Kubeflow, that is the Kubeflow Pipelines component. The main target of using such platform, such interesting and the eccentric platform is to using the automation component, which is the pipelines. So I think, at least to me, this is the most important. This episode and actually the next episode is the most important episode of this series. So uh, please be with me, and we have a lot of things to do today. So, as you may remember, in the previous episode, I made notebooks, which is a Jupyter notebooks here. And right now, I'm going to show you what's exactly a Kubeflow pipeline is. In this episode, I'm going to show you the general structure of the Kubeflow pipeline, and after that, maybe we can consider what's the and we can run the pipeline actually. And so let's do that. A Kubeflow pipeline is generally a Python file, uh, and you can run it in a notebook. And also, you can have a file in the YAML format, so you can use both of them, and I will show you how you can use both of them. But the main structure of each pipeline is consisting of components. Let's show you this diagram. Maybe it would be more uh, clear. So, I'm sorry. What's this? Okay, I have a network problem. Okay. I think it is better view of a pipeline, actually a DAG view of a pipeline. Each steps, I mean the green boxes, actually the boxes that has a green cloud and arrow, is considered as a component. We can see those in a code. And you can see the inputs or outputs of each component, which are these, showing with the folder icon. So, for example, we have a loud preprocessed data, and the name is optional. You can define each name you want. And then these steps produce the X train pickles and Y train, which are the feature and targets. And then we can pass these outputs of these steps to the model trainer steps for using those data to training the models. After training the models, we have logs, which is very beneficial information for using in TensorBoard. I will show you in future episodes. And the model artifact, which is maybe pickle or binary or everything that you need for that. And then after, we can evaluate the model based on the Y, which is good for predictions, and see what's the metric, which are the output of these steps. Okay, so again, each of these green boxes consists of the pipeline components or pipeline steps or pipeline part. Okay, and each yellow, actually orange folders or orange boxes or orange icons consists the output or input of those steps. So next, let me switch to the pipeline codes. Okay. Before everything, you need to. It is important you must actually import these components DSL, and also you have to import the KFP, stands for Kubeflow Pipeline. And from KFV, you have to load the components and import input path, output path for saving the path. Okay. So as you may remember, this is the component or steps of, for example, we have to use decorators, Python decorators to define the components. And then we have a function called load data, which is optional and you can use everything you want. And in this parenthesis, you have to define the output of or input. For example, here, this is an it's a next it is another component. You have to define the input or output of each component and the type. For example, this is a data set. This is output data set. This is input data set, and this is output model. Okay, the type is model. Okay, so after that, we have to import specific libraries or install specific packages. For example, that's a more complicated Kubeflow pipeline, and we have to install the packages. Okay, I will show you it a few minutes later. So after that, we have to tell to Python or Python interpreter to do what exactly. For example, here we use scikit-learn datasets and then load the iris. And then we have the typical data modeling and data training or data splitting or making a model or fitting a model. A step which is splitting the models and then saving those splits and then training the model based on that data. And for example, like I said, these are the input data set of this component, which is train model. Okay. And we have to again import, although maybe we already imported this in this component, we have to import it again. I will explain why. And then we define the model, we fit based on the X train and Y train. And after that, after defining the various components, in the last step, we have to define the pipeline. Okay. Well, we tell the Python interpreter or Kubeflow, okay, this is the pipeline. The function is my pipeline, which is the name of that. The pipeline consisting multiple tasks based on what you need to do exactly. Okay. And in each task, you have to use one of those components that you already defined here. Okay. For example, this is load data task and we use the load data, and these steps does not have any input or output. Okay. But as in the next step, which is the training task, and using this function, training model, which is this, okay, we have to load data based on the outputs of the load data. Okay. We are using the outputs of the load data task as an inputs. Okay, these are that's as an inputs data for this Kubeflow component or Kubeflow task. So, what's this? This is something from the last run. So, generally, and from the structure point of view, and from the syntax point of view, this pipeline does not have any problem. But after the running, we have seen that we have problem here. And actually, in this episode, I'm not going to run anything. I want to just show you what's the general structure of each Kubeflow pipeline. In the next episode, we are running a pipeline and see what's the problem here. And we will see actually. Let me show you another more complicated pipeline here, which has more steps or more components or more parts. Okay, as you see, it is a little bit more complicated. And like the other previous pipeline, after running, we have some errors here. Although from the syntax point of view or the structure, it does not have any problem. Uh, like I said, you can define your global variable here and you can use them in each steps you want. For example, that's here and maybe that's it. For example, the base image is the base image variable. Okay. We have to import a KFB, DSL, input output dataset, artifact model, and everything you need for running your pipeline. What it is important to consider or focus on these steps. Let me say what exactly happening here. Behind the scene, the Kubeflow for each component will run four separated containers. Okay, and those containers are exactly an isolation environment for running that specific component. Okay, so for running each component, you need to define what is your packages to install. For example, in this component, I need these packages. And if you need those packages again, for example, in another steps, for example, something like pandas, let me, for example, scikit-learn, okay? You have to define it again and Kubeflow will install it for you in that specific container. So again, each step is a separated and isolated container. So we need to pass the data between these steps, between the containers. Okay. So using outputs or input do these jobs in a good way for us. Also, we need to define the base image. Okay, for example, in these steps, in this component, I need Python 3.9 base image. Okay, although I have a general base image variable here which is the TensorFlow, but for this specific component, I need this base image and Kubeflow will install it for you on that container that I uh, mentioned before. But for example, in this component, I use the base image variable. Okay. So you can find this pipeline in my GitHub repository. Don't worry about that. I will put the link in the footer of the video, in the description part of the video, and you can just search my name, Amirian Far, in the GitHub and find my repository, which is the Kubeflow tutorial. Okay. So I'm not going to check these steps because these are the model learning and data manipulation for the model learning, and then giving the outputs based on OR methods. For example, this is the chorus, and after that, we will fit the model based on these variables and then save the model in this path. Okay. Uh, okay. So in the last component, as I said, we are going, okay, we defined or different or various steps of the component of or UI of our Kubeflow pipelines. And right now we want to say to Kubeflow, okay, start my pipeline. Okay. For example, for this pipeline, we have metadata, the name of the pipeline. Also, we can add description here. And then we have a function and then pass multiple variable, including epochs, for example, and another needed information. And the most important thing is that you can define requirements, hardware requirements not only for a whole the pipeline, but also for each separated or for each unique steps. Okay. For example, this is the task called data in a pipeline. Okay. I mean, the task was the green boxes that I mentioned before. So for load data, I need, for example, 4 gigabyte memory, and I request 4 gigabyte memory, which is the limit and request as we knew previously in a Kubernetes deployments. Also, the limitation of CPU core and the request of CPU core, which is the minimum and maximum number of cores for only these steps. So, if you remember in part one, I said I said the most important and most interesting functionality of the Kubeflow and Kubeflow pipeline is to adjusting the hardware utilization. Okay, so this is the power of the Kubeflow. And in a big organization, for example, in a big company that has at least 1,000 developers teams, the managing the hardware resources and hardware utilization is very important, especially the GPU resources. Okay, and then we can manage those resources easily here, and this is the main power of the Q4. Okay, we will discuss about how to manage GPUs maybe in the advanced course, but it is not in the scope of this course, although. So trust me, you can have a very good domination of the GPUs in Kubeflow. Okay, in next steps, in next task, actually, we have pre-processed data, which is this function. That's, for example. And again, we can say what is the output, what is the input. For example, in this task, we have these inputs, which are the outputs of the data task, which is this. Okay. So, and again, we define the requirements, hardware requirement, and then again. These are the multiple steps of the Kubeflow pipeline. And this is the running steps of each Kubeflow pipeline that we can have. Okay, let me run it and see what happens. We can see we can have no syntax error or something else, but after running this, we can see these errors. Okay, in this episode, I just wanted to show the structural point of view of the Kubeflow pipelines. If you have any question about the Kubeflow pipelines and the structure, please ask me in the comments, and the others can use your our question and answers. In the next episode, I'm going to show you how we can run a Kubeflow pipeline. So stay with me in the next episode, and thank you for joining me in this episode. Bye bye for now.